Hello, CoffeeJug. I'm not going to steal a lot of time from Piotr. By the way, Piotr, thank you for accepting our invitation. Just wanna remind you about one thing, one but important thing. Please support our Ukrainian armed forces. You can open any charity organization you know and trust and donate whatever it works for you and whatever is acceptable for you. Personal thank you for all of you and to organizers team. And Piotr, stage is yours.
Oh, that was rather quick. Hello, welcome everybody to this session, studying modern Java. I guess the date is okay. The time is also right. So let's do this. Quickly about myself, I work as a senior developer advocate for a company called Elastic. For search, you can find me on various social media, platforms and so on. I am also a Java champion, test containers champion. Every now and then I put stuff on my personal blog page, Software Garden as .dev as well. Basically, like to summarize me quickly, I'm just backend Java Linux nerd, right? So if you need to understand me better, I would say this is it. We were chatting quickly before this, before we went live, right? So if you folks have questions, because something I'm telling is not clear entirely, don't hesitate. Use the chat, right? We'll see your questions. You can also say hi, like where are you watching us from, and if the microphone works correctly, because like sometimes that's apparently an issue. And you can also tell us who you are, right? I'm especially interested in one thing: which Java version you're using, but in production, not on your like desktop machine, not on your developer machine, or you can put two, like production and like hobby machine. But I'm interested predominantly in the production JDK you're using. And little warning, I'm only a human being, and it's, as you can see, it's late. I already gave one talk earlier today, so I'm a bit tired. I might be therefore saying, or like weird words might slip through my lips, and not matching entirely the context, right? And that's on me. I'm sorry. And also, like, of course, don't make any like business decisions based on what I'm saying. Sorry, this should be Java 25, of course. See, this is the first glitch here. Java 25 was released, well, let me check, almost like 2 months ago, right? And it had 18 JEPs in total. It's a pretty beefy release, I would say. And this is first 9 of the JEPs. I intentionally, for the first time, I shuffled the order because I mean, not, this is not randomized, but because I think maybe it's better to sort of like cluster them. And it's not because I work for Elastic, sorry. It's just, in my opinion, these 2 or 3 come together, right? They allow us writing more concise code, which is better for newbies, for prototyping. These 2 are very, very nice when it comes to concurrency in Java, like modern view, modern approach to concurrency. This one is about better data-driven flows if we have such programs, right? There's also stable values, like I would say, like a cousin or relative of the scoped values. There's 10th incubator vector API, and it's going to be incubated in Java 26 as well, as far as I can tell. And there are reasons for that. There are valid reasons. I'll try to cover that if we have time. There are also compact object headers that can improve in general the performance of your stuff. There's generational Shenandoah, which is no longer experimental. Then we have a few AOT improvements. We see 3 JFR enhancements, and there's also, like almost as usual, there's something related to cryptography. For example, there are new algorithms or ciphers that need to be accommodated in JDK, and some outdated stuff has to be removed, like this support for 32-bit x86 port, right? Because apparently there's less and less need for that, especially for Java 25. So I would say thank you very much. That was it. You can follow the links and enjoy your evening. Of course, not I see that there's a bunch of 17s. There's Java 21, and there's also 8 from Julia. I'm sending you virtual hugs, Julia. I think that personally that the biggest the jump is between 8 and 9. Once you are able to do this, or these days between 8 and 11, right? Then keeping up to date with modern JDK is not such a big problem. And then there are, of course, like 2 things, right? And let me just discuss it quickly, because people oftentimes tell me, well, you have to stick to LTS. And this is clearly visible in this chat, right? So there's 8, 17, 21. We're only missing like what, 11, right? To cover them all. And then I'm asking people, why do you stick to them? They say, because they have like, because we need them because they are supported for longer, right? So yeah, when you look at this acronym LTS, S, my friends, stands for support. And it's kind of support that, you call someone picks up the phone, and you tell them, look, I believe we have found a bug in Java C compiler. And then the vendor, right, tells you, okay, let us take a look at this. Or this could be memory leak, or issues with, access to native memory, or something like this, right? Or like garbage collector going belly up. If you don't pay anybody for the support, what difference does it make if you upgrade your Java version, if you stick to LTSs or not? I mean, there's no benefit in trying to stick to LTS, especially that even the LTS versions are refreshed every 3 months. So if you want to stay, up to date, because there are some CVEs sealed, some other bugs got removed. For example, there are updates to root certificates or time zones and so on. You need to bump your like manifests or your Docker files every 3 months anyway. So then why stick to LTS if you don't have any benefits from that and you're just missing, some opportunities? So in my understanding, you shouldn't stick to the latest LTS. Okay, you can keep source code compatible with the latest LTS. This I can understand, especially don't go for preview features, right? But perhaps it would make sense to deploy on the latest JDK in production, because this means, for example, that's almost guaranteed the garbage collectors will get better and better, right? And of course, there are some really good excuses, oftentimes, or maybe not oftentimes, sometimes, right? And so it's not always, but it has to be, in my opinion, really good excuse not to have the latest JDK installed in production, right, as your runtime. And it's also because some people say, oh, because LTS is like not tested, or like it's not stable, something. This, I'm afraid, is not true, right? So all versions are tested and released equally. There's, as far as I can tell, the same level of devotion, right, to the details, to stability, being bug free, and so on. So really, if you have support, there's like paid support, there's reason. I understand there are reasons for to stick to keep using LTS. If you not have paid support, I don't see like why you should stick to LTS. In short, this new release, Java 25, has, in my opinion, no new concise language syntax, which is nice for prototyping and for newcomers. If you need to teach someone like teenagers or like a bootcamp people, you need to teach them how to use Java, then it's easier than ever, I would say. The stuff in concurrency, structured concurrency, scope values, the improvements to processing data. We see third preview of primitives in pattern matching. There, of course, improvements to performance, like compact object headers, generational Shenandoah, this ahead of time stuff, right? There is there are improvements to observability or tuning, all these JFR enhancements, and there's, of course, more, because in this talk, I'm not focusing even on beefy bugs or tickets, only on the JEPs, because we don't have that much time, apparently. Some of the things I'll be showing you today are so-called preview features. So the deal with them is the following. We, as the OpenJDK, I mean, this is like what the OpenJDK people are saying. We sincerely believe that this stuff is mature enough to be shared with public, but we reserve the right to tune it, to modify it, to do some breaking changes, or if it's really necessary, to withdraw it. And this was, for example, the case with string templates, right? After being previewed 2 times, they were withdrawn. There are like no string templates in Java, or any like string interpolation mechanism for that matter. Recently, structured concurrency got revamped / redesigned, not like a revolution, but a decent evolution, and so on, right? And some others are just working exactly the same version through version. So maybe it's not the best idea to toss this -- enable -- preview to your production code, unless you are using like it in a microservice and you run on your infra and you manage the infra, then perhaps, but not if you like running like, you know, creating artifacts and people run them on their premises, then perhaps not. It's easy to set that in Gradle, right? You need to set it to compiler, to test, and to runtime. Similar goes for Maven, right? For example, you can see Surefire plugin and compiler. If you decide to use them, you need to stick to them, and it's important. You will need to keep recompiling your code. I mean, even if there are no changes, you will have to use them, like recompile the code. Sorry, and there's no cherry picking. Cherry picking is only possible with incubation modules. Here, if you go for enable preview, you can use all the preview features. Basically, you cannot guard this. And also, like, this is slightly outdated. When you're like creating project, like let's say without Maven or Gradle, just directly in IntelliJ IDEA, for example, make sure you pay attention and set the preview level as well for your modules and for your project, right? If you decide to play with these non-GA things, right? So with that, let me go to the first first block, which is simple start and less ceremony. So we have 3 JEPs in here about compact source files and instance main methods. This got like renamed, and I'm not surprised. Naming is a hard thing, right? After all, in IT or in programming, there are flexible constructor bodies and the module import declarations. So let me go quickly through this. I want to ask you to raise your hand, because everyone would do that, right? So it's point of CD. Who has seen this piece of code, right? Everyone. And now we've all been taught this, and we've also been teaching this, like how to start programming. And we want this little program to just write this hello world, right? To actually do this, and the action is printing. So print line with hello world. And there's so much stuff around this, right? There's this public class hello world, and this public static and void and main, and this string and these brackets or 3 dots and arguments, and this system out, and people are like, what does it mean, right? And then when we say like, trust me, you will get there in a week, but for now it's just like, assume it's necessary, like accept this, I'll explain it to you later. And this is kind of like silly, because this scares people off, right? So instead of this, since Java 25, we can do just this, right? And if we do the static import of IO, we could do even without this IO and dot. So as you can see now, the signal to noise ratio for like simple prototyping got easier than ever before. And I'm really not sure if it can get any easier, to be honest, right? Because the reasoning is we still need to tell people that there's the main function, like entry point to your program, right? And it doesn't return any value, therefore it's void, right? It can have some arguments, there are none. This is the body, and IO was added after previews, just to make sure that people understand that this is input and output, right? So this is it. And implicitly declared classes and instance main methods, so the string args can be omitted. Main method doesn't have to be public or static. This can be, for example, protected instance method, right? The order is like, if you have a method like with the same level of visibility and it's overloaded, right? And you have string arguments, then it will take precedence over the no arguments variant, right? They work with interpreter. So, I mean, you don't go with Java C, so you get .class file, and then you run this class file with Java like class path or -jar or whatever. You can, if you have like this, your program written in a .java file, you can just run Java your program in .java file, right? It will get compiled like in memory. And in some degree, it also works with scripts. By default, they import the module Java base. We'll get to that. And they used to do that in the previous versions, but they don't do that now. So that's the difference, right? They don't do the static import of Java IO. There's not even IO. has been moved to util, Java util. So maybe let me show you. So if you're trying to teach someone how to program in Java, let's do the following. Let me go, maybe not here. By the way, the code should be available for you online, right, and slides as well. Let's just create new compact file. Yeah, how convenient. Let's call it whatever, right? And this is it. As you can see, this is basically it. And then if I want to, sorry, let me go for edit mode. If I want to, for example, print something, I can say io dot print line, and I can say privit, for example, right? Let's try to run this stuff, and as you can see, it works, right? Yeah. Like this. And then let's say we want to, like, we are exploring the realm of programming, so we can go and say, for example, list dot off, and we can say, yeah, just like here, A, B, and C, because why not? And then we want to, for example, print it again, so we go io dot print line, not privit, but sorry, I missed the assignment. List, sorry, list. Maybe try to make me let me make this bigger. Let's try to print this list now. Let's see what happens. This talk will be about experimenting with stuff, right? So as you can see, it did this. And please pay attention to this. We didn't have to import anything. We don't even have to import the list, although list is what is it? It's Java util list, right? Something like this. So we don't have to import this. Why? Because like implicitly, what we have is this module import, and I will tell you in a second how it works, right? Yeah, okay. Flexible constructor bodies is the other thing. So we used to create this many static, factory methods to create actually some objects, because we needed, for example, to validate the arguments, right, or the input. So we needed to make sure it's not null, right? And then we were able to create the constructor of the class, because all of this was illegal before Java 25. Let me actually go and jump to the code, right? So as you can see, this code compiles now, right? So before Java 25, this couldn't have happened. So if I run this thing now, as you can see, it's suddenly working. So I have this new with legal statements before super, and I pass an argument, right? And this is a constructor. Okay, so I can first assert if it's not null. If it's not, then I can even fetch and override the value of the inputs, like from somewhere else. I could even, in theory, do like IO call here. I don't think it's a good idea in general. Just because you can doesn't mean you should. Let me try to rerun it a few times to prove it or to show. Yeah, see, not so sure if fetching constructor arguments from the outside is a wise idea, even if legal. So this is legal in terms of syntax, but I wouldn't necessarily go this way. Anyway, we can like prepare more arguments. As you can see, we can assign value to the fields coming or existing in this class. So if we go to this field, you can see it's part of this legal statements before super, right? There is this field, but and then I have these two arguments, and I can call super. So I can do the whole like validation checks. This is in my understanding, the spirit it should be used for. And also like to assign some fields in local class to ensure, for example, that equals and other stuff works in hash code correctly from minute 0. What we cannot do is this thing. For example, we cannot assign value in a super class. It works only for this, right? And we cannot call instance methods, or we cannot read the value of the field. So I cannot do this another field, right? This is illegal here, right? Let me just try real quick. I just got curious, see, it's legal here. It's pointless, but it's legal. And it's illegal to do it here because it's before I call this or super. See, so I'd say it's it's a change I'm very happy about, right? Because this reduced like boilerplate, this sort of artificial factory methods. Right now, the constructor can be used for what it was intended to, so constructing the objects and also validating it. It sort of started behaving like this with records, right? When we could have these non-canonical records and assert stuff, but now it's even better. Like to see it working and behaving like this in my understanding. Yeah, let me roll this back. Very nice. Yeah, so now we can handle arguments before we call super or this. We can validate the arguments and even compute them, although I wouldn't necessarily compute them unless it's like predictable, like we had this length based off the input, then maybe. But is it really object-oriented programming? I'm not so sure. They don't allow conditional jumps. They, of course, work with records and enums. We can call static methods, but we cannot call instance methods. And that's, I mean, if you think about it for a few seconds, that's only logical. And we can assign instance fields, but we cannot read them, these fields. And we can also read outer class fields, and it also makes sense because if I'm in a nested class, right, it means the outer class has been already assigned or initialized, so logically it also makes sense. There's more. I mean, I'm not able to run all this code tonight with you. I'm sorry, but there are, for example, illegal statements here, right? So yeah, we can do like try, for example, this conditional jumps. As you can see, this is not going to work like this. You always need to be predictable that this is legal, and you cannot like call this or this like randomly. You always have to be like it has to be deterministic flow, where which this or super is going to be called, for example, and so on and so on. In case you would like do something quite naughty, so please don't. Yeah. What else? Yeah, module import declarations. So modules are a thing in Java since Java 9. They didn't really, went wild in use in like public code. Maybe that's good, maybe that's not good. I don't know. They were primarily intended to be used by the JDK itself. So to make sure that there are, not weird connections between one piece of JDK into another piece, or like, let me say, like code region of JDK. That's why there are modules, and modules are basically a cyclic directed graph. And now the thing is, we can import everything, right? So instead of these classes, right, if let's say I need something like this, right, and then I need to specify which date I'm gonna use. So let's say util.sql. So normally I have this thing, right? But maybe instead of this, I can just go for, oh, sorry, this was meant to be SQL date. Let me roll back real quick. Import class SQL. Yeah. By the way, like, don't use date in 2025 unless you really, really have to. Use, please, like Java time something, please and thank you. Yeah, so as you can see, I have this list of imports, and maybe what I can have is basically have just Java base and Java SQL imported, and then I should be able to remove this thing, right? So I can have like regular package imports. And this is not working because it's ambiguous, right? So I need to go and have this SQL date to make sure there is like if this like date class imported from this module and this module, then I need to make sure like which one is it going to be precisely. And in case you were wondering what classes are available for me after importing Java module, it's all the classes that are exported by one of the packages grouped inside this module. So all classes in here are available, so I don't have to then go and import this class and that class, and don't have this lengthy list of imports, right? I can just have Java base. And as I have shown you here in this whatever, right, this is by default. So I can go like import module Java base, right? But as you can see, it got just removed because this is the default. If you have this a file with implicit class, you always have Java module imported. Therefore, for example, people who just learn Java, they don't have to go and say import Java util list. It's because it's the list is part of Java util, and that's part of Java base. So that makes things simpler, I hope. I'm not sure if that's good approach for the big projects that's supposed to be maintained for years and so on. Maybe you should still be picky about the imports, but if you have to prototype something quickly or teach someone programming real quick, then I guess it's quite useful because it's less ceremony, right? So we do it just like this: import module m, and that of course brings transitive dependencies. So if your module depends on another module, then that other module will be imported as well. If I'm not mistaken, in case of a clash, as we have seen with the date class, you have to say explicitly have to import the class because the compiler wouldn't know from which module you'd like to do it. And I think it's quite fortunate, right? Because someone could say, oh, this is the first one, so let's just go from this first one. Or someone could say, no, just let's have the second one because the second one overrides. All right, and we need to have like clear, verbose, maybe some would say over verbose, but I don't care, way of doing this. That's why then you have to be super explicit about this, which class exactly you want to have if classes with the same name appear in more than one module you're importing, right? But this is like pretty much like the same like we have with the star imports, right? Let's talk about two features that got moved from experimental to production, and this is generational Shenandoah and compact object headers, right? So as far as I can tell, there's been like not that much done. It's just now you can use them without experimental flag. So in Shenandoah, which is JEP 521, you can click them if you get slides, and they will take you to like the JEPs, the documentation. And I encourage you to read these JEPs, especially the alternatives section. So this one is JEP. This JEP is pretty short, but the other ones can be really beefy, like for example, structured concurrency. Anyway, single generation is still the default for Shenandoah, unlike ZGC, which went generational, right? And now it's even impossible to run without generational, like in single gen mode. So in Shenandoah, single generation mode is still the default, but you can opt in for the generational mode for Shenandoah without using this unlock experimental VM options like in Java 24. I mean, if you still have them in some scripts or run configuration or something, Java won't yield at you. It's now useless. It's no op when it comes to this generational mode, right? So it turns out every major garbage collector now is generational when it comes to Java, and because there are like proven reasons for going in this mode. The other thing is compact object headers, and this is again prod mode in Java 25, thanks to Roman Kenke. All right, so in short, it's about using less memory, less CPU, and less time. And it's not enabled by default. You have to enable it, maybe because, I don't know, in your very special program it won't work, or something like this, or the performance gains will be really small, or maybe even negative, if I may say so. So previously you had to, in Java 24, enable it with also in like unlocking experimental VM features. Now you can just go use compact object headers, and this JEP is like, if I'm doing this correctly, sorry, here, see, they say depending on the benchmark, like you see 22 less heap space, 8% less CPU, garbage collections reduced by 15%, or like the time needed to run this thing was this parallel JSON benchmark was 10% shorter. Right, so I don't know how it works for you, for your use cases, for your programs, for your systems. But see, this is like, maybe it was worth doing exactly this already in Java 24, right? And save this 10% without waiting for Java 25. See, this proves my point why sometimes LTS releases, I mean, we are needlessly waiting for LTS releases. And it doesn't say anything like you have to recompile your code or worse, rewrite your code to feature Java 25 features. No, that's not the case. You can still have, class files compatible with, say, Java 8 or Java 11, as long as they don't use or rely on deprecated API. You can run them on Java 25 just fine, and then benefit from these compact object headers and less memory, less CPU, and less time. See? Yeah. Let's jump to another thing, which is primitive types and patterns, instance of and switch. It's preview feature Java 25 as part of JEP 507. And I guess we all recognize this code, right? So this code, this is how it used to be before Java 23. So if we wanted to cast integer, but mind you, like primitive type, not the object types or the uppercase integer, but just int, right? And make sure it fits into byte. We need to manually compare it if it's within the size, for example. We can use it as byte type. We can do the casting and we could print it, right? Or we could just say I cannot use it, because if we didn't check, right, suddenly, for example, we might lose some data. So like it was prudent to do this check before casting, right? If we can sort of like cast it down without losing stuff. And now we can also use it with instance of, right? So I can say this integer is check if it's instance of byte, for example, and 142. I mean, I leave it as your homework, right? Or I guess let's be honest, you already know which branch of these will be executed, right? And then we know that it can or cannot be used as byte value, even for these primitive types, right? There's more. So we can do this switching, and we can go with this case byte, right? So we can say if it's like this thing, this guy, then we go this approach and that approach. This is the equivalent of this. Basically, it's just a matter of preference, or how many branches do you need to have, or how many types do you have to try, for example. Yeah, we can also go for true and false. I'm not so sure if it's a wise approach. I'm not so sure if we should use so-called like the Boolean switch, right? But technically, it's doable. We can do it like this, and we can also use guards, right? So we can also say, as you can see, when it's 0. And by the way, now we can use long, because previously we couldn't use long, right? Only like ints, shorts, and bytes. And for example, enums and strings, and like quite recently records. Now we can also use long. And if it's 0, then we can say 0. If it's less than 0, we can say it's negative. And then it's not negative. It can be 1 digit, but it's positive, of course, like positive 1 digit. Then it's below 100, and then it's, let's say, unexpected value. And then we can have human description of the stuff we have. So guards are also possible with this when. And this when should have been colored. The truth is, I haven't upgraded JavaScript library that does the coloring of the syntax for Java. Maybe they do it now. I would need to check. As you can see, the version from like 1 year ago didn't do that. Right, so this should also be. Let me actually check it. Maybe I have it in IntelliJ, in IDE. If I have this code, yeah, see, I do. And here it's colored properly, right? And we can even like run this. Let's see if it works. Yeah, it works, right? So as you can see, I have the array of longs, and for each long, I can say if it's 0, I can just try if it's long of 1, and then I can check, for example, it can be casted to be like integer, but at least 2 and no more than 10. Then I say below 10. So 0 and 1. So this was caught at 0. This was caught at 1. Then 2 was caught here, right? And then when we went to 99, it wasn't caught here. It got caught here because it was casted down to float, right? So as you can see, this works really, really nicely. And there's more. There are more examples here. You can run them. Actually, this I prepared quite a bit of demo for you here, so you can run them and see, I mean, how do you like them or not. If you don't like something, or if you find a corner case that you think it shouldn't be behaving like this, if you have found a bug, you think, then of course let the OpenJDK people know. This is also the purpose of the preview features, right? And you can see it's kind of like yellowish in my screen, and it's because IntelliJ lets me know that I'm using preview feature here, right? This can be disabled if you find this color annoying or something like that. Yeah. So, yeah, and they can also be used in like wrappers. So let's say when we have like this record and wrapper, right? So we can now deconstruct records. It's like in Scala, this unapply method, right? If you happen to use Scala. And yeah, so now we can also, when we have this wrapper, let me check if I have wrapper here somewhere. Wrapper install. Yeah, okay. This thing, so we should have it here. Yeah, I can use wrapper 42 as byte value. So as you can see, when I'm doing something like this, it checks that this byte can be, sorry, not byte, this 42.0 can be used as byte. Let me minimize this so it's like nicer to clear to see. When I go, for example, 142, what do you think will happen, right? Let's run it, and as you can see now, it says it's integer value, right, because it's an overflow for byte. But when I go to 42 and let's say 0.3, then when I rerun it, then okay, it can only be used as double. So as you can see, the thing is actually quite smart. I would say it works as expected. And here are the rules, how it works. So there are no new conversions added. So everything, I mean, all the rules to convert between primitive types as they used to be, they still apply. There's nothing new, nothing fancy here. It's only that primitive matching pattern matching can handle primitive types now, including long. Conversions can be unconditional exact, so we can always cast float to double, and you don't have to worry, right? It will always fit, or like, let's say, integer into long. Sometimes they can be exact, so we can check, for example, that the long of 1, 2, 3 fits into byte. Then it has to be checked. So it's like this first if I have shown you, right? Or they can be rejected because let's say this is 132. Then it's too big, and then it will tell you, oh, no, it's not a byte. It cannot be used as byte. And all primitive types can be used in a case. Of course, this is like only logical without dominating patterns. So I cannot first check double and then float. Let me go here and let me try this. See, it's a legal statement here. Why? Because it's obvious. If it's int, it can never be byte, right? So this is the dominant case, and these are not allowed, and these are rejected by the compiler, right? And they have to be exhaustive. So it's like how it works with pattern matching these days. So you have to be sure you're covering all the cases. In the worst case, or if you cannot do them, you have to rely on a default. And let me maybe like see if we have something here. See, like here, let's see if it can work without default. As you can see, it can't. Why? Because I'm checking if it's 1F, or then I would need to just have something that catches something always. Let's say case float F, even without this guard, right? Something like this, and now it's exhaustive, right? So I either have this, and then it's of course not below 100. It's just a float, right? Float, right? Or I have the default. I encourage you to run this thing versus this thing and check the results, because the precision comes into play, right? So we have to be mindful. As I told you, all the conversions still apply, right? So you shouldn't be very much surprised here. Okay. Oh, Victor is using 8, 17, 21, and 25. We have the winner. We have someone who's using Java 25. Very nice, Victor. I'm happy you using 25 in production already. I'm a bit sorry you still have to use Java 8, but it is what it is. Let me talk about another thing, which is structured concurrency, and it's not third, it's fifth preview right now, and it got revamped in Java 5.05. If I was to summarize it in 2 words or just in a few words, I would say that if you have ever been programming in JavaScript, modern JavaScript, you should be familiar with the concept of async await, right? So this structured concurrent, because that's an idiom. That's an idiom how to do stuff concurrently in JavaScript. And structured concurrency is going to be, in my opinion, Java's way to have async await, roughly speaking. Not exactly, of course, but putting us in that direction, right? So it's about better idioms for multi-threaded code, which still, I mean, you can still think of your task in terms of, okay, I can divide my big task, my big beefy task into smaller subtasks that can be run concurrently, and then at the end I just somehow, I either select the best one or the quickest one, or I need all of them to get my final result, something like this, right? And it helps to eliminate thread leaks and cancellation delays without touching current concurrency stuff. So this thing doesn't remove anything, it just adds sort of like new idiom, and for sure it doesn't replace interruption with cancellation for now. And this is how it may look like, right? Let me actually jump to code. Let's go structured concurrency here. Oopsies. Let's roll back, or I don't have it like formatted properly. Yeah, sorry. Yeah, so let me first run the code as we used to do it so far. Let's say since Java 8-ish, more or less, something like this. So what we have here is, first let's check if this code runs, because running code is easier to explain usually. And I spoiled it, sorry. Or maybe I didn't. Actually, I didn't, right? So you are facing the following task. Let's say, you know how it's like Olympic Games, and you have like the track, right? So the athletes are running, and for example, who is the fastest for 100 meters? And you have several batches of them, right? And there's the scoreboard, and you have the name and the time, right, of the runner. And let's say you are about to create a system that will do just this. Only the system for this display board can call, or has to call, 2 other systems. One system can translate you the athlete's numbers. You know, they have like the like numbers, right, on their chest or their back or leg or whatever, right? They have number, so they will translate the number to the name. And the other system, when you ask for the like the time for the athlete, giving athlete's number, it will give you the time. So one system gives you let me put it like this: user ID and score, and the other one puts you user ID and name. And to display it beautifully in this board, you have to call 2 systems, right, to have it right. So the first approach, the sequential approach, is most naive one, right? How we start doing stuff. So we get names from one system or one service. We get scores from other service. Let's assume these are like network calls. So these are like different microservices, for example. And then we combine the results, and we have something to display. And this is the results. So Joe has 100, Susan 100, and Krzysztof has 300. I don't know if it's worse or better. I don't know. All I know, it's just it took more or less 2 seconds. It's because this call takes 1 second, and this call takes also 1 second. So it's easy to say like 1 second and 1 second, and then this is like very, very small or short in memory operation. All right. So this is this little overhead, right? And yeah, but then your boss tells you maybe you could run it faster, right? So then what we used to do, we used to go for these futures, right? So we have this executor service, something like this, and we can submit, and we get one future, which is like names future, and the other one is scores future, right? And then these 2 happen concurrently, and we have the names and the scores, and we can combine the results. So now, if I run this, how long do you think you should take? It should take, and you can type in the chat like if you think it takes 1 second, 5 seconds, 2 seconds, 0 seconds, because it's not going to work, right? Just let us know, and I will continue, because I believe we have like a few seconds delay. Yeah, so when I run this now, it takes more or less 1 second, and it's logical because these two are fired like almost instantly. They do their stuff sort of like in background or in meantime, and we have the names. I wish that was like 3/4 of the seconds, right? But that's not the case. I'm sorry. Yeah. The thing is, there are at least two problems with this. First, I can take this future and I can like put it wherever. I can even like serialize it and say send somewhere, maybe, although that wouldn't work, I guess, but I can assign it to, I don't know, like my field in my class or something like this. So it means this futures and therefore the threads can like leak. And then there's this other thing, and let me show you this other thing. Okay, let's say that we have this name service, right, or better said score service, and this is how it looks. You see, it's like sneaky slip. This is how I know it takes more or less 1 second. And let's say that the thing breaks here. So after 1 second, instead of giving us the user scores, right, it just breaks. So how long will it take before we know that the whole thing doesn't work? Right, let me run it, and I guess like we figure out correctly that the oopsies will happen about 1 second, right? Because it was waiting 1 second until we got the results, right? And it got oopsies because without this thing we cannot like display half of the board. Like the whole board would just turn into like blue screen. Okay, so this is sort of like obvious, but let's think for a second what will happen in this case. How long will it take us to see this oopsies message in this case? Will it be 0.73 seconds? Will it be 0 seconds, 1 second, 5 seconds? How long will it take? 3, 2, 1. Okay, you can pause the video here if you're watching this later, okay? And after you have your bet, unpause it, okay? Cool. So let me run it here, and you see the time is also 1 second, and you might be, what the heck, it breaks instantly, it doesn't wait right now. Yeah, this score service doesn't wait. That is true, but the issue is here, right? It's poorly written code, because if this guy fails instantly, it doesn't this future, it doesn't notify and cancel this other future, hey, you should break, right? There's no point in waiting. Just finish this and go home. So we have 1 second instead of 0 seconds, and this would like require, if you have only two futures, right, this would require that the names future informs the scores future, hey, just stop, and vice versa. So with two futures we have two interactions. With three futures, what we have 6 interactions, because each of the 3 has to notify the other 2, so that gives us 6. With 4 futures, it's higher mathematics, and therefore it's called callback hell, right? And as you can see, what you've seen here in this case is this cancellation delay, right? We need to cancel something, but we've forgotten, and it just runs happily, and it only figures out here that it shouldn't have waited, right? Or run this thing. Yeah, so what we can do instead now, we can try this structured concurrency. Sorry. And it looks like this. As you can see, the code in terms of like, you know, how it visually presents itself is pretty much similar. Instead of executor service, we just open structured task scope. Instead of submitting stuff, we just fork stuff. And this is maybe important. Instead of futures, we have subtasks here. So this is a subtask, a piece of a bigger task, right? Yeah, and now the the one extra thing we have to do is we have to join this scope, right? So it's sort of like we're waiting until all of these subtasks are complete, because by default this is the case. This is if we don't toss any parameters to open, it means we're waiting for everyone to finish, and then we get the computation results, and as you can see, we combine. So in this regard, it's not that much different, right? So let me run it, and again, you will be able to pause here and just tell me how long will it take to run this thing. See, we're not throwing any exceptions, everything runs. So it takes, again, 1 second, and it's no surprise, like it won't squeeze the silicon or your RAM or network. You won't get results faster. However, when we get here and the thing explodes instantly, and now when I rerun this very code, as you can see, it stops in no time, right? Because what we get here, thanks to structured concurrency, is the automatic cancellation. And also, we cannot or we won't have the thread leaks. Let me show you what I mean when I try to misuse it. All right. So first thing, if I forget about this scope join, what will happen is this. Am I using this correctly or not? Sorry, let me check if it's this thing, or maybe I have forgotten something. Yeah. Okay, I know why. Because I'm still throwing the exception. Silly me. Sorry. That's why I was confused for a moment. If I run this thing now, is there still something not okay? Let me run it. Yeah, we have to join it, because if we don't join it, we won't get the results, right? So make sure you call join or join until, and you can toss a timeout here, if I'm not mistaken. Sorry, maybe it's not join until. Let me. I will show you that in the slide for sure. So we have to make sure we call the join, right? And the other thing is this. See, now I'm trying to sort of like call this scope, like to have a fork in a separate thread, in a thread that wasn't started by this scope. So when I run this thing now, it tells me, oops, like no current thread not owner. So this is the current thread trying to fork another task. So this is not leaking. What I can do in this fork and this legal fork, I can do like sub forks or like of course subscopes and so on, right? But I cannot use can do like forks on this scope if I'm not in this so-called herd, if I'm not mistaken, or in this gang or band or something like this. So these are the important things not to forget, which we have to do, right? And it's, yeah, the free cancellation within the three. So now if we forget about this, we don't have to worry about this, right? If we have this default mode, and the default mode with open is like every subtask must complete successfully, and successful is understood as not throwing an exception. So if it gives you like 404, for example, when you're doing microservice call, it's still seen as success. You would need to throw an exception, or you would need to create your own stuff, sort of tune it, because now you can, when this open also accepts parameters. So the default is this: await all successful or throw. So if not at least one of them of the subtasks is not successful, it will throw an exception, letting me know, right? But I can go in for a different mode. For example, one successful, and you might be wondering, but what was it needed for? For example, I have super fast cache, I have regular cache, and I have database, and I need to decode the username into, for example, user's full name or email address, right? So instead of like trying first quick cache, no response, right? Cache miss, then trying this regular cache miss, and then trying database, what I can do is like I can try all of them at the same time, and then whoever answers first is a success for me. Right? I can tell the other two, look, we're done. Like no point in doing what you're doing. Just finish. Like stop. Thank you very much. Right, so this is we can choose different modes. We can also change the config, so we can use the different name, so then it would be easier to debug in JFR, in thread dumps, and so on. We can change the default timeout, right? Or we can change the thread factory, because by default this is using virtual threads, which I remind you don't pin since Java 24. Right, another reason why it was worth it to jump on Java 24, not waiting for Java 25. See, but if you need, for example, good old, fashioned threads, because let's say you're not doing any IO, but you're doing CPU only, then maybe it doesn't make much sense to go for virtual threads, so we can configure it, right? And this is like new pattern, something like this, so it should be like lowercase c. And we also use it, for example, when you're running the latest client of Elasticsearch, right? When you're running the Java client of Elasticsearch 9, then there's also the same way to configure to just toss the, for example, server URL, or that's just called like URI. You can toss the API key the same way. You can toss, for example, custom SL context, and that's it. This is how you configure your Elasticsearch client. And as you can see, it's also nice because it works with try with resources, the thing we have since Java 9. So then the scope is automatically closed here, right? You cannot use it any further. So what this gives us, right, when you look at this code, you clearly see structure of this code, right? So we think about it, this code looks sequential almost, right? You just decompose the big task into smaller tasks, right? But under the hood, until this moment, it works in concurrent way, right? And it makes sure we don't have cancellation delays, or we don't have thread leaks. Yeah, so see, this helps. I'm not sure, maybe it was Nikolai Parlok who said that this approach with completable futures is unstructured concurrency, by difference. So this is structured, and the old way is unstructured. Yeah, and don't forget join until. This quote is not from me, it's from good Dr. Venkat Subramaniam. You know this guy, right? Extremely smart guy, if you ask me. And he said that completable future has no future because of this. Once this thing gets production ready, when it gets GA, it will be a super nice thing. And I have my own comment to this. So this is like me, when you use completable future after it gets GA. Right, and this is what happens when you use virtual threads or structured concurrency, right? Marit can only be happy about this thing. Hi, Marit. Yeah, let's talk about scoped values, which are a standard feature, which are GA in Java 25, and they are about like being. This is my explanation. Okay, one-way immutable thread locals with bounded lifetime. And this lifetime is visible in code again, and this gives us simplified reasoning and improved performance. Why? Because thread locals are still working. They don't change because they're still needed in some logical flows and so on. Like, so we cannot say, let's get rid of thread local. No. It's just they are an overkill for many situations. Let's say you have this million of virtual threads, right? So then if you have a million virtual threads and each of them would have their own thread local, we would have million thread locals. And do you really need to have the thread local for million virtual threads if it's, for example, always the same value, right? So it's always the same value. You can put it as a immutable thing, and then you don't need to have million copies, because if it's immutable, just one copy is okay, right? There it is. And this is how it looks like at a glance. So we create a field, right? Pretty much like with thread local. So we say, for example, that we create this new scope value. And then when we have it in the where clause, we can just say that in this scope values, where region or scope right? We say this scope value to be this thing, for example, value from HTTP request, and then we can call, for example, run, and we do some logic, and inside we can just say, we can, for example, get the value of it, or just call like, or else, or we can check if it's for example, bound or not. Maybe let me show it this to you in the code. Scoped values demo, but not this thing. I should have something maybe easier to start. Yeah, this thing. We have to go deeper, right? So this is how it is, right? Let me just comment this thing real quick, then to show you how it works. Why I said it's really nice, and lets us clearly see when the thing is working, right? So let me run it, and it should display something like this, like we have to go deeper, if you know what I mean. And this is how it's created. See, so I have the scope value of type string. Folks, really, seriously, like, please buy all that secret to you. Make sure this type inside is immutable, because if you make this mutable, then like the whole thing is just pointless. Basically, it has to be immutable. Okay. Yeah. So we have an immutable message. And we have this spin message, which just basically says, spin method, which just says message.get and prints it, right, using this new IO class. And this is what we see here. See, in scope value, we say in this scope, let me show you, like maybe visually, in this scope, from here until there, in this scope, we say that message is we, unless we override it for a subscope. Unless we override it for a subscope or nested scope, whatever it's called, right? Unless we override it deeper, and then we have to maybe even there go deeper with this right? Because it's just method reference. I don't need to have lambda. And this is how we ended up with we have to go deeper, right? In our terminal. What happens now if I just uncomment this unspin? You should be able to figure out, I guess, that it will print us go. Why will it print us go? Because deeper ends here. This is the scope where the message is bound to deeper. And once we exit this scope, it's reassigned to the value it was set in the outer scope, right? So therefore, we have go here. If I move this code, let's say here, what we shall see is have, right? Because this is C where 2 was set, and have is now unspin is called in the scope of have. So this is it, right? And you might be saying, oh, why is it needed? For example, you are running like a transaction in banking system, and your job is to show the statement to the client of the bank, right? So you see, this is like the account ID or a client ID, right? And you say the ID here. And it's not leaking somewhere, because if I put the unspin, let me show it to you. If I put the unspin here, sorry, too much. If I put the unspin here, and when I run it, unlike thread local, right? If I forget to clean thread local, then, you know, if the worst case scenario, the thread will get reassigned somewhere, kaboom, right? Suddenly one person sees the bank statement of another person. We don't want to do, we don't want this to happen, right? So therefore, as you can see, that's why it's called scope value, because this is the scope where this value is assigned. All right, and when we go, so this is why it's very nice and safer, right? If the thing is not mutable, if you have unmutable thread locals that don't change, I think you should instantly go for scope value. You will thank yourself later, really, or the people that will maintain the code after you. And why do we need these nested scopes? Let's say you're using a logging library, right? And this is the bank statement. You're like printing the bank statement, and here you want to, like, this is not spin, but this is like log method. Does log method really need to know the like, for example, account ID or user ID? right? If it doesn't need this, you just put it into a scope, which is basically like no. And then you do the logging here and you exit the scope, and that's it. So it can be seen as a safety measure, like you know, according to the smallest or the least privilege principle, right? Something like that. So let me roll this back. So these are scope values. Maybe let's go to the end and we'll see if we have time to answer these questions. Maybe I think we should have time to answer these questions. But let's finish first. So we have scope values, right? They work nicely with structured concurrency. So this is this other demo. See, when I run this thing, they work with structured concurrency because this do stuff is actually forking its subtasks. So if you decide to go for this thing eventually, or maybe even now as preview feature, then you have to know that scope values work beautifully with structured concurrency. If we can use run, you can use call if you have callable, not runnable, right? Depends on our use case. And these words can be nested, you know, like this wooden door, like door inside a door and so on. Like we have to go deeper, basically. Yeah, a few other stuff or minor things, maybe. I mean, I won't be covering everything today. Very nice article about the changes to G1 parallel serial GC. All right, there's a whole series for every JDK release. There is also Vector API and its 10th incubator. And people, I mean, before I didn't like used to run this demo, but today I'd like to do this just to show you, and this will be a demo from my other talk, the one I'm doing with Marit. Okay, so what you'll be seeing here, first of all, Vector API is part of project Panama, if I'm not mistaken. And why is it incubated for at least 11 times? Because for this thing to be GA, we need this value object from Project Valhalla. Right, so this is sort of like parked until Project Valhalla gets GA, and Valhalla being GA enables a Vector API to go GA as well. It's because of that. And let's say, and sorry, the other thing, if you want to run this demo, you have to make sure that you go for, you have to cherry pick this incubator module, right? So you just toss add modules to compiler or Java C. And what you see here, by the way, I'm not sure if you're aware of this, since Java 24, we can use Markdown for Javadoc, right? So this Javadoc, let me show it to you. See, this is like properly looking Javadoc. It will also get rendered like as HTML files, right? But you can now write them in Markdown. Since Java 24, just go three slashes, and this is how it starts. The task is following. I have two arrays of 10 million, if I'm not mistaken, right? This array, that array, and I need to calculate results. Right, and I have two ways of doing this math operations. So one way is just good old-fashioned Scala, and this is just this interface, as you can see, for math ops. So I can calculate dot product. I can add two values, right, and then I store the result in third value, third array, or I can calculate the Euclidean norm. And you might be wondering why these three. Well, these are, for example, very useful in vector search. That's very popular these days. You know, if you want to build semantic search or context search, something like this, right? When you want to run vector search, these are very useful, right? And also like more operations. So this is the interface, and I can implement it in two ways. So one way is, for example, and this is the obvious way, right? If I need to calculate the dot product, right, or maybe like summarize, maybe summarize is even simpler, right? It's done simple. I iterate, you know, for every element to get every element, and I say like element from array A plus element from array B, and summarize it and store it in array C. Obvious. This is how we used to do stuff for years, right? And this is the most intuitive approach. And similar, of course, for Euclidean norm, which is normally calculated like this. But I can also implement this interface, and this might be useful if you're, for example, if you have to crunch a lot of data, right? Really like just like Elasticsearch, you can set the thousands and thousands and hundreds of thousands, for example, vector embeddings. Then you like the more data, the more numbers you crunch, the better it can be utilized, right? Or there's also a new language called ESQL, Elasticsearch SQL language, that also has a brand new engine, not just syntax but also engine, right? That's using exactly this what I'm about to show you. And the thing I'm using here is the class vector, which is also implementation for math ops, but it works slightly differently. It just relies on these vectors, right? And these are not vectors as in vector search. These are vectors as like you can think like slices or wrappers around arrays, for example. That's oversimplified, but it will do. So what we do here is like I'm creating a double vector according to the specifications, right? And I create vector A and vector B, and I take vector A, I add vector B, and I store the result in array C, right? And then I need to handle remaining ones. This is like with the division, for example, 16 times so divided by 5 is 3, and the rest is, or the modulo is 1, right? So this is for the modulo part, right? And you might be wondering, okay, why is it working like this? So the explanation is quite simple. If you know how the CPU works, right? So CPU has registers, and let's say your CPU has registers of size 128 bytes, and you are summarizing, for example, not doubles but int, and every integer is 32 bytes. So then when we add integers using this approach, it means that in one register we store 32 bytes, and the remaining of 128 is wasted, is not used. And the same here, and the same here. So the idea is, no, instead of just putting one integer into this register, let's put as many integers as we can. So in that case, we will put 4, like 4 integers, 1, 2, 3, and 4, right? That would make 128 bits. So we put 4 first elements from this array, 4 first elements from this array, and then we run single CPU instruction. That's why it's called SIMD, single instruction multiple data. And then one CPU instruction will give us 4 integers in this C array, right? And this can make your stuff run faster. And the beautiful thing about this is that Java discovers like what silicon you're running it on, right? So if you deploy it on like your desktop Mac, like I'm doing right now, you will get certain results. And if you deploy it to, for example, one cloud or another cloud, you might also get different results, right? Based on your hardware, basically. So let me run this right now, and let's see the results. Yeah, of course I got the warning. I'm using incubator modules, right? And see, this is why it's different performance characteristics. It's not always faster, right? It really depends. So as you can see, running a dot product, it's like 2 times improvement on my machine. And so is the Euclidean norm, but the speed up for addition is actually negative. So this means you need to like run proper benchmark, run proper performance test for your systems, your use case scenarios, and so on, right? And let me now rerun it. Maybe the results will be different. By the way, this is not the proper benchmark, right? And now, as you can see, this is slightly worse and this is slightly better. And funny thing will happen if I unplug my laptop from power and will run it on battery. You will also get different results, because then the operating system or the motherboard or something puts the CPU into different power profile, basically. So if you're running like benchmarks on your laptops, please make sure you do it on battery and when connected to power, right? You might be surprised sometimes they work differently. Yeah, so and you might say, okay, yeah, but this is not that much used. Let me try to show you one more thing, because I'm running Elasticsearch locally on my computer. You can just go Google for this. If you want to run Elasticsearch and Kibana on your machine, and you just have Docker or Windows subsystem for Linux, just Google Elastic start local, and you'll be taken to a GitHub project, right? And let me go here, and let me go and exec, and let's go and see what processes I have here. So P is PS args, and let me go and just grab, maybe not grab, just go CAD. Why I need to get CAD to wrap the lines. See, and these are the processes that are running inside this container, and this also will tell you why maybe using Docker image is easier than running it on bare metal, because all of these things. And what I'm looking for here is, I'm not sure if I can see it instantly. Let me maybe just copy this, right? Let's run it faster. Let me just copy this and create, sorry, here, let me just take it away, and let's create a new simply a new text file. Yeah, it's in this other project, yeah, but like let me do it here. Okay, not Java, but like in the resources, and let's go and create new file, test.txt, and let's not add it, let me just run it, and let me just find this add modules and see. This is it. So if you're running the official Docker image, container, right, for Elasticsearch, you're already using this module, because in many situations it makes your stuff go faster, right? So maybe if you're crunching data, you should also be running the same stuff. And also, like I asked many of you, like which Java versions you're running. Let me go and show you this thing. Right, because this is this J-linked image, and go and say version, and as you can see, it says Java 25. Right, so the deal is, when you're running Elasticsearch, it's using the image is using the latest Java version that was available at the time when this image was released. So let's say if you were using, if I'm not mistaken, Java 0.1, it was using Java 24, although it wasn't LTS. Again, why? Because all of these improvements, for example, to G1, to a Vector API, and so on and so on, right? So if, in my humble opinion, if you're not using the latest JDK, you're just missing opportunity. You're creating more CO2, and you're just burning money. Yep, simply put. Okay, some stuff got deprecated. So as I said, this port got removed. And let me try to answer some questions. There are two questions from Orest and Julia. The question from Orest is, yes, how does JVM internally handle pattern matching on primitives? Is it optimized at JIT level or implemented as simple as range checks? The honest answer is, I don't, I'm not sure, right? So I don't want to give false like answers here, but I think like it should be like, get yourself the class file, right? Decompile it, and you shall see, not about the JIT, right? But you can see how it works with syntactic sugar. I'm pretty sure it's syntactic sugar, and then the JIT rules apply nevertheless, right? And how it's actually like desugarized, I can't tell you right now, Orest. I'm sorry about this. There is a question from Julia. Is new switch pattern pipeline fully stable, or do you expect some changes in 26 plus as these features may mature? Good question. Well, I can only speak for myself, right? I cannot speak on behalf of like OpenJDK or Oracle or any other JDK vendor. I rather think they won't change, at least when it comes to primitives. They would stay as they are, and the reason is the third preview, right? And there's been no changes, at least when it comes to syntax. I mean, you still need to recompile the code because it's a preview feature. So even if there are no changes to the syntax, each JDK JVM only understands the preview features of its own version, right? Not of the previous ones. So we still need to recompile it. But I don't remember a single change here. I remember one change. There was a change when we were talking about, these extended switches or pattern matching. So initially, we've been using return, and now it's using yield, right? But I would still like suggest go for this lambda style, this style with arrows. And also the thing about like these guards, now we're using when keyword, and that was also changed like pretty quickly, I think. So I can't guarantee you this, but I don't think this will change, because this is also how it works for everything else except primitive types. The primitive types are the last to this pattern matching party. I don't know what's planned next for in Project Amber for this. In my personal opinion, would be very, very nice to have like deconstructors, right? So like in Scala, we have these unapply methods. So I have whatever class, and it just has a method unapply, and I can deconstruct it in pattern matching in Scala. And the other thing is like people are waiting. Of course, it's like somewhat related. It's not exactly this. Is this wither pattern or whatever we call it? It's just so we can create a copy of a record, for example, with just one or two fields different, right? And it's interesting how it's going to be solved eventually in Java. I cannot guarantee you anyway. But then you see, sorry, little detour, how beautifully Java works as for language that's supposed to be dead, right? Almost since I started programming in Java, like well over 20 years ago, I was hearing, oh, it's dead language. As for dead language, it's developed pretty well, except for the next question from Victor. Will there be any future with string template or something better similar? Honestly, I think Java is cursed when it comes to string interpolation. The previous attempt with string templates was that it was meant to give the same like power as regular string interpolation, and also toss like some security or certainty on top of it, right? So to sort of like to kill two birds with one stone. And this was to make sure, for example, we can construct like a better JDBC drivers and stuff like this, or like and the other third-party clients and so on. The thing is, turns out these things are already solved. So string templates came like too little and too late to the party, and therefore it wasn't needed. And as far as I can tell, even internal feedback at Oracle was pretty, we don't need this. Let me put it like this. Will this happen? I don't know. I think there's a chance eventually. First there was like raw strings, which was something different, but still around strings, right? Got unmerged from Java 12, if I'm not mistaken. And then string templates were withdrawn after 2 versions. And this, I sincerely think there is a potential. So when they find something that will retrofit nicely Java, we will have it. What won't happen, and I'm really sorry about this myself, is like a proper collections library, or maybe it will happen, but the chances for this I estimate like pretty low. There's sorry, let me go for the slides so I can show you a QR code, because I'd like to, folks, to always and everyone at every event to share your feedback with the speaker, with the organizers, right? What was okay, what wasn't okay, what you were missing. I know it's almost like 1.5 hours, right? And I've been talking quite fast, and for some aspect we barely scratched the surface. Or I didn't run some demos, but as you can see, it's like a beefy release. So how could I, right? That would require like a proper, like a whole day training, maybe even without lunch, right? So this is an anonymous survey. I promise you the QR code is for this link exactly, and it will open like a small Google form. So when you're watching this now, please like scan it in the meantime and let me know what you think about this talk, right? If you're watching this later on YouTube, also do the same, because I check these forms even later. And also, like, please make sure you hit the like and subscribe buttons. It's not my channel, it's CoffeeJug from Lviv. This question from Andriy. Oh, привет, Andriy. Do you know what happened with GraalVM after the Oracle announcement of detaching GraalVM from the Java ecosystem train? How shall I answer this? I might know something, but for public and recorded events, I would suggest there should be someone with proper authority from Oracle, talking about these things, not like a sort of like random minion with opinion. So I'd like to whistle out from this question. Sorry, Andri. We can chat privately, or I guess better approach would be just to chat with someone from Oracle. Maybe Alina Yurenko would be the best person to answer this. I don't know. It's up to her. I mean, she's from Lviv, so you guys may want to just ask Alina about this thing. I don't think we have any more questions, so let me just do quickly this. These are my socials. I'm also like LinkedIn, Mastodon, whatever, right? You can. I'm not on TikTok or Instagram. Sorry, I'm too old for this, perhaps. If you like to see the slides or everything from this talk, this is the link or the QR code that you should capture right now. So you have now 5, 4, 3, 2, 1 second, or you'll be able to watch the recording later. Right. This is it. Thank you very much for having me. I really, really regret I can't do this personally. I mean, I know some CoffeeJug. I mean, some folks standing behind CoffeeJug. I also know the great coffee in Lviv and the maybe even better chocolate. Right. So, but it is what it is. Unfortunately, for me, and even more unfortunately for you. Back to the studio.
Hope you had a great talk. Thank you, Piotr. Thank you, audience, for being active in the chat and posting questions. Hope you. Thank you for sharing this evening with us. And yeah, thank you, Victor, as well. Wish you good luck. Stay safe, and see you tomorrow. Thank you.
Yes. Thank you very much. Sleep well. And